Good evening, my friends and followers. My name is Edward Washroom, the tutor in Edward's Academy. This evening, we are going to consider how to simulate an arch graph and how to test for the presence of an arch effect. In this study, we are going to adopt a study approach in which we want to forecast the volatility of spot price in Nigeria for the period spanning 2016 to 2022. We are going to consider a 75 years observation. A 75 observation moving a monthly time series data that spans from 2016 to 2022. And to have that achieved, the first thing we will need to do this evening is to examine or to visualize the spot price series. This is the spot price series we have from 2016 month 1 to 2022 month 3. So we are going to use this particular time series data for the study. The next thing we are supposed to do is to plot the graph of this series. If I decide to plot the graph of this series, I will be exposed to a two-dimensional graph that looks like this. This is the graph of the series. This is the graph of the series, and it shows an evidence of a unit truth problem. It shows an evidence that the spot price actually is having a unit truth problem, is not stationary. So this evidence of non-stationarity actually will require us to stabilize the time series data. So the next thing to be done is to go to view. Let's look at the ADF value of this spot price at level. We move on to view. We allow it at augmented Gefiula. We'll leave it at level, a trend, and intersect. We click the OK button. We observe that this particular time series, this financial time series assets have a unit truth problem because the probability value is greater than the threshold of 0.5 and the T statistics in absolute term is less than the critical value as 5% level. So given these conditions, we now conclude that this series does have a unit truth problem, and to have that normalized, we can go to view. From view, we maneuver to unit truth back. We move to first differencing, hit the OK button. At this level, the spot price has been normalized. The unit truth problem has been actually solved. But recall that the essence of this class is to test for volatility, to test if there is presence of volatility clustering or not, and to also simulate a graph that shows the volatility, and finally to look at how to test for the presence of arch effect. And to have that done, this spot price variable we have to look at it again to see how we can generate the return of the spot price series. To have that done, we move over to generate series. In the eView work file, there is a button called generate series before the sample here in the upper bar. So we'll look at this button. If you hit the generate series button, we'll now calculate or generate a new variable, a new series, which is the change in the spot price series. So to have that done, we'll now say spot price R. We're looking at spot price rates equal to bracket open spot price, the current spot price minus the previous spot price, which is spot price lag 1, bracket close, divide by the previous spot price. We now have spot price minus 1. Spot price minus 1, and we hit the OK button. If you hit the OK button, we have actually generated a new series here, which is known as the difference or the change in or the rate of change of the spot price, which is this This is the new series I have just generated with the code I used. So to look at this series again, this series spans for the period under investigation. The only difference is that the first month was actually removed, because when you difference a series, the first period will actually move out. So to proceed, you go to view. From view, let's look at the visualization, the graph of this particular series. You go to graph. From graph, you still leave it at line graph, two-dimensional graph, frame and size. We come to the frame border, we select 2 dimensions, hit the OK button. What we have here is the spot price rate, which is the rate of change. If you look at this particular series, this series seems to be stationary, because we actually have the Sigma line within the steady state equilibrium, and at this stage we are seeing a near volatility clustering, where a calm period is followed by subsequent calm periods, and we have a wild period within 2020, and before another near wide period, and another calm period followed. So basically, we are actually seeing an evidence of a volatility clustering. This is how we can actually generate our volatility graph to actually conclude that this series is stationary. We move back to view. From view, we go to unit root. From unit root, we move to the augmented, the fuller text. We leave it at trend and intercept, because our series has trend and intercept. We hit the OK button. You can now see that the new series that we have generated has do not have a unit root problem. Rather, it is stationary at level, which actually means that the series we are working with is now volatile. So this is how you test for the presence of the volatility in financial time series assets. Then the next thing we are supposed to do is to test for the presence of arch effects. We need to actually look at what we have done to see if the new series we generated has an arch effect, because if there is no arch effect, then we need to proceed to estimate an OLS. But if there is an arch effect, that means that we have to proceed to either estimate the arch or any variant of the arch modeling system. To proceed, we will now come back to our EView work file. We go to quick. From quick, we maneuver to estimate equation. From estimate equation, we now estimate the new series, which is the spot price. The spot price R, we give a space spot price R lag 1. Lag 1. We, without changing any other thing, we hit the OK button. If you hit the OK button, the estimation method remains the least square. If you hit the OK button, you will be exposed to a least square output that looks like this. From this output, you go to view. From view, you maneuver to residual diagnostics. From residual diagnostics, you maneuver to heteroscedasticity test. From heteroscedasticity test, you move over to arch text. Within this heteros text, we have too many of them. We have Bruce, Godfrey, Pagan, have a Glacier, Arch, White, Custom test. So you select the arch test. You select the arch test without changing the number of lags. You now hit the OK button. If you hit the OK button, you'll be exposed to an output that looks like this. This is how the heteroscedasticity test appears. And in this test, we have the F statistics and the observer root square, and we have their probability values. So to test, to actually conclude there is an evidence of arch effect in this estimation, is that we assume, or we actually check if the p-value of the F and arrow square are statistically significant. If the p-value is less than 5%, we will now conclude yes, that there's an evidence of arch effect in our study, in our estimation. But if the p-value is more than 5%, we will now conclude that there is no evidence of arch effect in our study. At that instance, we will now proceed to estimate an OLS. But what we have here, we have p-value of both f statistics and f and observed rate square that are less than 5%. So given this condition, we now conclude that there is an evidence of heteroscedasticity in this variable, and which is the main reason why we are actually on the arch model. We are desirable to have this result. We are happy because the arch model require the variable under consideration to be heteroscedastic and not homoscedastic. So given this condition, we will now proceed to estimate an arch test. So stay tuned to my video. In my next video, I'm going to teach you how to estimate an arch model and also how to interpret an arch model. Thank you for listening to me this evening. Subscribe to my channel. Thank you and God bless you.